Okay, so this video will be on building an atom. You will need your periodic table for this one. So we're going to look at different subatomic particles. We have protons, electrons, and neutrons. And my guess is at some point you have heard of these things. So your protons and neutrons are located inside your nucleus, and then electrons are outside of the nucleus. And so what I want you to pay attention to is these are typically the two kind of visuals you see when you look at if you Google chemistry, for example. So this one is like the Bohr's model, which we'll get into in a little bit. And then here it's showing how the electrons are around the outside of that nucleus. Okay, so let's first look at protons. So protons are positively charged subatomic particles. They're found in the nucleus. What I want to point out is that they're super heavy compared to electrons. In fact, one proton is equal to 1,840 electrons. Then we also have, if it's a neutral atom, the positive charge of a proton is equal to the negative charge of an electron. That is for a neutral atom. And that the periodic table is arranged in an increasing number of protons. So to figure out how many protons you have, we're going to look at your atomic number. And the atomic number is equal to the number of protons. So usually we have our mass number on the top part, and our atomic number on the bottom, and then our elemental symbol. I also wanted to point out the different ways that we could write protons. Now, electrons are negatively charged subatomic particles. They're super small, but they're the ones that really show the chemistry. They are located outside of the nucleus, and we'll spend the next unit really talking about that part. So the atomic number is equal to the number of electrons for a neutral atom. So that would be the same as the protons if it is neutral. Things will change if we have something called an ion. An ion is a charged atom, meaning it's either gained or lost electrons. And so a cation is a positively charged atom because that T is like a plus sign. So it is positive because it's lost electrons. So if you think about it, it has lost some of its negativity, becoming positive. So aluminum, for example, is a +3 charge, which means it has actually lost 3 electrons. Now, if I'm looking at Al like this, or Al with a 0, that means it hasn't gained or lost electrons. It's whatever electrons found by the atomic number. Now, anions, they are the negatively charged atom because they've gained electrons, so they've gained negativity. So notice that minus charge, that means it's gaining 2 electrons. And so what you'll find is metals tend to lose these electrons and nonmetals tend to gain them. So to find our neutrons, we're going to take our mass number minus our atomic number. So a neutral, it is a neutral subatomic particle also found in the nucleus. It does contribute to the mass of the atom, and that atoms can have differing number of neutrons, which means that we have an isotope. So I have down here a picture of hydrogen and its 3 isotopes. So deuterium and tritium are isotopes of hydrogen, meaning they have differing number of neutrons. And sometimes you'll hear like a listening question like something about deuterium, for example, which is just a differing number of neutrons. So if we actually have water, heavy water is made with using deuterium instead of our typical hydrogen. And actually those ice cubes made out of deuterium will sink. Also, I want to point out that often we identify an element by its mass number, so carbon 12, carbon 14, and that allows for us to know the differing number of neutrons. So I want to make sure that you do know how to find the protons, electrons, and neutrons. So for each of these elements, if you look up their atomic number, and you should do this on your own and you can check with the periodic table, that's going to be equal to the number of protons, and that will be equal to the number of electrons for it being neutral. Then, to find your neutrons, you're going to do your mass number minus your atomic number, and that will give you your number of neutrons. So I'm not going to go through this right now in this video, but I could point out for calcium, for example, it's usually written this way. So here we'd have 20 protons. We're going to have 20 electrons, being electrically neutral, 40 minus 20 would give us 20 neutrons. And then I'm going to add, if I ionize this guy with a +2, that means it's lost 2 of its electrons, then it would have 18 electrons. Also, I want to point out you should make this mass number here a nice whole number because we cannot have partial neutrons when we do these calculations. Okay, the last part I wanted to hit is the average atomic mass. And basically what happens is we don't have nice whole numbers in the periodic table because what they are showing us is a weighted average based on the relative abundance of each isotope of a particular atom. My guess is at some point you've heard that there are different types of carbon, for example, and so that mass number is taking into account how abundant those different isotopes are. So if you look at the periodic table, it has atomic mass units, and that is a unit of mass equal to 1/12 the mass of carbon-12. So everything is referencing carbon-12. Now, you do need to be able to do this. This was something we're going to do with the Beanian lab, and it's called finding the average atomic mass. So you're going to take your percent and convert to a decimal by dividing by 100. Then you'll multiply that decimal by the mass and then add each isotope together. There's absolutely no division. So I have this example here. And so here's my masses, and then here's the percents as decimals. Now, if they give you, so here I said carbon-12, and then they give you data, let's say 12.001 or something, use the more detailed number in the calculation. Okay, so if you'll notice that these were then added together after multiplied by that decimal. So I do have one practice problem here. I want to make sure you know how to do it. So it's finding lead's average atomic mass, knowing it has 4 different isotopes. I do want you to pay attention as sometimes those really small numbers are the ones that get messed up. So let's go ahead and do this. We're going to take that decimal, so it's 0.014. I'm going to multiply that by my mass of 204. I'm going to add my decimal, 0.2410 times that mass of 206. I'm going to take my mass of 0.22, well, my mass percentage of 0.2210 times my mass of 207. And then lastly, 0.5240 times 208. And if I solve this out, I find it to be 207.241. And when you do these calculations, I want you to double check and see if that answer makes sense. So looking at the different masses given, I knew it would have to be between 204 and 208. So first check, is it between 204 and 208? Yes. And then I noticed that this almost over 50% is 208. So my answer is probably going to be closer to 208. And is 207 closer to 208? Yeah, it's a little bit bigger than that 207, a little bit smaller than 208. So that answer does make sense. You could always double check that these percents converted to decimals add up to 1, and that your percents do add up to 1. Now, if you are given an element and it has just 2 isotopes, and let's say one is 80% and they don't tell you the percentage of the other isotope, I'm assuming that you could figure out that the second isotope would be 20% and still find the average atomic mass. I have also embedded extra practice for you, and let me know if you have any questions.